right, so.
Stop! And you get mad at me, it's a lot of fun.
Julia, take this.
We gotta make it from both sides, Jordan. No.
Was this water or
That
was
scares me. Why are we filming so bad?
Because, yeah, Ellie's not here. Guys, stop. So, let's get going.
Like, what? Why does it feel like it was years ago? Yeah, that was yesterday.
Mr. Chen.
What? For the noise I made, I was like,
So,
what do you do?
in this case, hi.
Oh wait, Julia.
Now, so while you got, the rest of you are cleaning up, we're going to quickly go over the calculations. I will ask you all
Does
to
that mean it's just for me?
twin.
I'm listening.
Okay. Yeah, I know, but you're talking. So in this case, I'm going to go over the calculations, and later on we're going to go do the analysis together as a group. Okay? Because this is an important practical where you can be tested for it. So that's why. Now, the whole point of titration, yeah, it's recording that side, is to help you find out the concentration of whatever you're looking for. In our case right now, we were titrating to find the concentration of the vinegar, which is acetic acid. That's the formula for it. So this is a chemical reaction happening during the titration. You have sodium hydroxide, you have acetic acid, gives you sodium acetate plus water. It is a 1 mole ratio reaction, so in some ways it is simple because this is your first time. So in this case, we know the concentration of the sodium hydroxide. Titration helps you to find out, first of all, you find out what's the volume of the sodium hydroxide used. So using this group, so you guys got 45.5 to start and then ends with 35.9, am I correct?
That is right.
So you end up using 96 mils or cubic.
9.6 mils.
What? Yeah, 9.6 mils, thank you. So 9.6 mils or 9.6 centimeter cube of volume. Now, keep in mind concentration needs to be in decimeter cube. So in this case, just move the decimal place back. So in this case, 1, 2, 3. So it will be 0.1296 decimeter cube. It has to be that. Okay. So you have concentration in 0.1 molar. You have volume in this. You will need to find the number of moles. Okay. To find the number of moles, it is concentration times volume. So in this case, it will be 0.1 mole per decimeter cube, because molar just means mole per decimeter cube times 0.0096, which will give you basically one more zeros, so 0.00096. Am I correct so far? That looks right. So that is 0.00096 mole of sodium hydroxide. Are we good with this so far? Now, because it is a 1 mole to 1 mole ratio, this also means that because 1 mole ratio, so it also means that the number of moles of acetic acid, HCH3COO, is also 0.00096 mole. Right? Yay, nay, huh?
Yes.
Now, we we know the volume is 10 milliliters or centimeter cube. So in this case, we change that into liters. So in this case, it's 0.01 decimeter cube. So now we have volume, we have number of moles. We can figure out what's the concentration of our diluted vinegar. So in this case, concentration equals number of,
That was you.
oh yeah, concentration equals number of moles divided by volume. So in this case, 0.12396 divided by 0.1 decimeter cube. So in this case, just move decimal place to 1 to spot back. So it's just 0.096 molar. Okay.
Did anyone else hear Quinn?
It's the same thing because molar. That's a good question, Julia. Because molar, 1 molar is the same thing as 1 mole per decimeter cube. That's what 1 molar means. That's a unit.
So capital M is molar.
Yeah. So in this case, we know that our diluted vinegar is 0.096 molar. So our original vinegar, let's look at the procedure again. So our original vinegar was, what was it? Your original vinegar was 10 mil and 100. 10 mil. Okay. You dilute it down to 100. Okay. So in this case, what it means is using the formula C1V1 equals C2V2. This is diluted vinegar volume. That is your V2. That's your V2. Your original vinegar, directly from the bottle, you only use 10 mils of it. So that's your V1. This is actually your C2. That's your diluted concentration, right? So this becomes your C2. The microphone is just right next to it.
That's why we're laughing.
Yep, that's why.
So
No,
in
you
this
did.
case, we're looking for the original concentration of the original vinegar, so which is C1. Okay, C1 is original concentration. So in this case, C1 to V1 equals C2 to V2. So we don't know what C1 is, but C1 we can isolate the C1. So C1 equals C2 times V2 divided by V1.
Didn't know way before.
With and Rachel.
Jeez, Rachel.
So we're gonna plug in the numbers. Oh yeah, forgot one thing. Change all the volumes should be in liters.
Always.
Guys, change all the volumes into liters. So in this case, 0.01 decimeter cube. This one will be 0.1 decimeter cube. So C2 is 0.096 mole. V2 is your 0.1 decimeter cube. Your V1 is 0.01 decimeter cube. So in this case, unit cancels out. This move 1, 2. Yeah. So basically you multiply this, so you end up having this, and then move 2 decimal places back. So you end up getting 0.96. Am I correct? Yeah. 0.96 mole. That's the concentration of original
Winter.
vinegar.
Just all trying to figure out.
Yes.
God.
Didn't we have that at the start?
No.
Pretty much though.
Thank you.
Like the numbers only change from the zeros back and forth and back.
Because we use a simple example. When you are actually doing
Yeah.
your IA, you better not do anything that ridiculously simple,
Jeez.
which is unworthy of your 10-hour lab time.
10 hours?
You're really
Okay.
good at putting on the stress.
I'm not putting on the stress. I'm putting in correct perspective.
Which is pretty stressful perspective.
So
Okay, are we okay with this calculation so far?
Not again.
So,